good morning or evening or whatever, whenever you're doing your notes here. Let's check this out. We're in section 3.3 still. We're talking about logarithms. And we did a notes page, we did a homework page. This will be the second homework page. So like I usually do, I will do a couple of examples and then give you the assignment, and you will finish this on the same page, unlike the other. Anywho. So let's start. We're on page 309, I guess. No, 308. Page 308. Okay, you should have the appropriate notebook page written there. And let's look at number 43. Okay, 43, it says f of x equals natural log of negative x. F of x equals natural log of negative x plus 3. And just writing that should feel weird to you. You can't take the natural log of a negative number. The domain has to be positive. Well, this just means that x has to be negative as well. So negative will give you that positive. And it says describe how to transform the graph of y equals natural log x into the graph of this function. So transform y equals natural log x into that. Okay, sketch the graph by hand and support your sketch with a grapher. So I can already start by saying, well, natural log looks like this. It has the point 1, 0, and it has the point E1. So it has those 2 points. Okay, so natural log of x, negative x plus 3. What are the transformations? Sketch the graph and support it with your grapher. Go ahead. Okay, we're back. Let's see how you did. A negative at the x. That is a y-axis flip. Plus 3 at the end. That is up 3. So let me see. It was kind of... Okay, that's my graph. Let's go ahead and sketch this. So a y-axis flip will be both those points to the other side. And then up 3. So I would have, this point at 1, 0, flip it over and then move it up 1, 2, 3. Okay, and then I have the point E1, flip it over to negative E1 and then up 3. So this will be negative E4. So, I don't know, put it right about there. Okay, and let's go ahead and graph this to see if it is anything like that. Hopefully it's just like it. That'll make me super happy. So y equals, let's graph this, natural log of negative x plus 3, natural log of, negative x plus 3. Negative x plus 3. I bet you were screaming at me. All right, let's see. Zoom, I'm going to zoom decimal. Oh, zooming decimal was a bad idea. I can't see that stuff up there. So let me adjust the window. The y max go up to, I don't know. Oh, up to 4, maybe a little bit more than 4, 4.4. I want to see that point up there. So let's graph it. Now this looks like it might end at 0, but it doesn't. If I type in trace and then negative 10, no, negative 0.001, so a number very close to the y-axis. If I type that in, that's all the way down at negative 3. So this line does go beyond the x-axis. It's just the resolution of the grapher. You can't see that very well. I can type in these numbers here. I can type in, negative 1, and I get 3. So the point negative 1, 3, that was correct. And then I could type negative e. Negative e, I'll use what's above the division key, negative e, and that gives me 4. So the point negative E4 was correct as well. So that's what that graph looks like. I've confirmed it with my grapher, and everything is great. Let's try 2 more here. I want to do number 55. Number 55. Number 55. 55 says graph the function, analyze for domain range, continuity, okay, all that stuff. So 55, describe all that stuff. I'm going to put it right here, and then I'll put my answers right beside it. So it is domain, range, continuity. Increasing or decreasing. Boundedness, extrema. Symmetry, asymptotes, and behavior. Okay, so describe all of this stuff. My function for 55 is negative natural log of x minus 1. Negative natural log of x minus 1. So go ahead, get your grapher out, and fill all that stuff in. I will give you a minute. Pause, please, for crying out loud. All right, we're back. Let's take a look at this in our grapher. I want to graph negative natural log of x minus 1. And I guess we could have done some of this stuff just by thinking about it, knowing our transformations, but let's go ahead and graph this. Okay, so we can see the graph, instead of starting the domain as x is 0, x greater than 0, the domain is now x is greater than 1. It starts there. If I type trace and I put in 1, well, I get nothing. There's no value there. But if I type 1.00001, something just barely greater than it, I get a value of 25. So I can get very, very, very close to 1, but not actually all the way. And eventually, if I type enough zeros here, the calculator will round my number off, so it will give me 1. So if I type 80 zeros here, well, it won't evaluate, because at some point it has to round off that value of x. So it lost that 1 before it plugged into the function. That's why I don't get anything here for that value, because it just rounded it to 1. Anywho, so the domain x is greater than 1. The range is all real numbers. You might say, well, it's not there. Well, yeah, I guess, but that's just because the calculator is limited. Okay, it only goes to x is 1.1. What about at 1.01? At 1.01, I go up to 4. What about 1.001? That goes up to 6.9. What about 1.00001? That goes all the way up to 13. So this does go up to infinity eventually, as long as I choose appropriate values for x. So that's just because the calculator didn't pick any of those numbers. If it had picked them, we would have seen it better. This grapher does not handle that logarithm, that vertical asymptote, that logarithm very well. The calculator doesn't handle vertical asymptotes well in general, so that's where you have to interpret it. Okay, so the continuity, it's always continuous on its domain. Continuous on its domain. Is it increasing or decreasing? It is decreasing. I could also say on its domain. Is it bounded above or below? No, the range is all real numbers. The range would have to stop somewhere if it was bounded, so it's not bounded. Any maximum or minimums? No. Maximum or minimums happen between increasing and decreasing sections. So if it doesn't switch from increasing to decreasing, you're not going to have any extrema. Is it odd or even? No. Any asymptotes? Yes. At x equals 1. And behavior as the limit as x approaches infinity of the function, I'll just say f of x, is, well, as x goes off to infinity, what is it doing? Well, it's approaching negative infinity. And the limit as x approaches 1 from the right, okay, we have this other end here. It doesn't go off to infinity, but it ends here at 1. As x approaches 1 from the right, it goes up, up, and away to positive infinity. So the limit as x approaches 1 from the right, from the positive side of our function, is infinity. So a lot of stuff there to remember. If you remember all that vocab, hopefully I've talked about it all enough that you're finally sick of it, but at least you hopefully know it.